Atlas Foods produces the following three supplemental food products simultaneously through a refining process costing $93,000. The joint products Alpha and Betters have a final selling price of 4 per pound and 10 per pound respectively, after additional processing cost of 2 per pound of each product are incurred after the split-off point. More feed, a byproduct, is sold at the split-off point for 3 per pound. Product Alpha, 10,000 pounds of alpha, a popular but relatively rare grain supplement having a caloric value of 4,400 calories per pound. Betters, 5,000 pounds of betters, a flavoring material high in carbohydrates with a caloric value of 11,200 calories per pound. More feed, 1,000 pounds of more feed used as a cattle feed supplement with a caloric value of 1,000 calories per pound. Assuming Atlas Foods inventories, more feed, the byproduct, the joint cost to be allocated to alpha using net realizable value method. We have to find out the joint cost to be allocated to product alpha using the net realizable value method. Here is the solution. For product alpha, the sales value is $40,000 and the processing cost is $20,000. To find out net realizable value, sales value minus processing cost gives us the net realizable value, that is 20,000 for product alpha. For product betters, the sales value is 50,000, processing cost is 10,000. To find out the net realizable value, sales value minus processing cost, $50,000 minus $10,000 gives us $40,000. The total net realizable value of both the alpha and beta is $60,000. We have found out the net realizable value. Now we have to find out the relative net realizable value percentage of both the products. To find out the relative net realizable value of product alpha, we have to take the net realizable value of product alpha divided by total net realizable value of both the product alpha and betas. 20,000 divided by $60,000 into 100 gives us relative net realizable percentage of alpha as 33%. To find out the relative net realizable value of product betters, the net realizable value of product betters divided by total net realizable value of product alpha and betters multiplied by 100 gives us the relative net realizable value percentage. $40,000 divided by $60,000 into 100 gives us the relative net realizable value percentage of product betters as 67%. Here, product alpha constitutes of 1/3 of net realizable value in $60,000. Product betters constitute of 2/3 of value to be allocated from the total net realizable value of $60,000. We know that the joint cost is 93,000. Byproduct is 1,000 pounds into 3 per pound, that is $3,000. Joint cost equal to $93,000 minus byproduct, that is $3,000, gives us the $90,000 to be allocated between product alpha and betas. We have to find out the joint cost allocated to product alpha using the net realizable value method. We have found out that relative net realizable value percentage is 33%, that is one third of the total net realizable value multiplied by 90,000, that is the joint cost, gives us 30,000 as cost to be allocated to product alpha.